Have you been ever worked as an IT for the big organization that have high volume of connected computers? And how did you manage to divide these high volume of connected computers into smaller groups for having secure, stable, and organized network infrastructure? So be with me till the end of this video to understand how to organize and manage this big network infrastructure into smaller groups by using VLAN or virtual local area network. First, let's see what is the problem in our network. In this network setup, we have over 400 devices, possibly more connected. Imagine what would happen if each device starts sending and receiving a broadcast message across the network. What do you think the impact would be? Definitely, we all know if the size of broadcast domain is larger than expected, it will affect our network performance and even its stop or down our network infrastructure. So how we can overcome this issue? The best and good solution is to implementing the VLAN or virtual local area network configuration. And before configuring the VLAN, let's check the connectivity between the computers and this network infrastructure. Let's ping PC4 from PC1. You can see the ping is successful. Now let's ping PC3. Also it's successful. And finally, let's check the connection between PC1 and server. Wow, all the connections have been done successfully. Now we reach to know what is VLAN. VLAN is a logical grouping of devices on a network. And without VLANs, all devices should be in the same or sharing the same broadcast domain, which can lead us to congestion and security risks. So now you might ask, why do we need to use the VLAN on our network? There are 4 major points we should configure the VLAN for our network infrastructure. First, it is improve network security, means VLANs isolating traffic, so sensitive data stays within its VLAN. Second, reduced congestion, means VLAN minimizing unnecessary broadcast traffic. Third point is flexibility. You can group devices by function, department, or any criteria you choose, regardless of their physical location. The fourth measure is cost efficiency. Instead of creating separate physical networks, VLANs allows segmentation within one network infrastructure. This is our basic network infrastructure. PC1, 2, and 3 are connected on port first Ethernet 01, 02, and 03 in switch 1, and PC4 and server are connected on first Ethernet 02 and 03 on switch 2. Now we can separate these connected computers into 2 VLANs by separating the ports on each switches. We can move PC1, 2, and 4 into VLAN 100 and PC3 and server into VLAN 200. Physically, they are in the same LAN, but logically, they will be separate into 2 different LANs or VLANs. In the second stage, let's configure the VLAN for the network infrastructure. For this network diagram, I have prepared a diagram inside the Cisco packet tracer, and we will implementing all the VLAN configuration on that. For the VLAN configuration, we have 4 steps, but before these steps, we have to prepare our diagram in the packet tracer and make sure that all computers have the same configuration as I showed and have the same IP range. Thereafter, let's first configure the VLAN on switch 1. Open the switch 1, and after you have opened the switch 1, you can see a CLI or command line interface. I just write all the configuration on the notepad You can copy it and paste it. We have 4 parts. The first part is basic configuration, and it will help us to enable only to enter into the configuration mode and assign a switch name, as I assign SW1 for switch 1. In the second part, I have created 2 VLANs, VLAN 100 for HR and VLAN 200 for the finance. Just copy this configuration and go to the Cisco switch terminal and paste it. You can see both VLANs has been created. Now let's come to the third part. In the third part, we are assigning each interface or port into its specific VLAN, as I have assigned first Ethernet 01 and 2 into VLAN 100 in switch 1. Also assigning interface first Ethernet 03 into VLAN 200. And came to the last part to check if the VLAN configuration have been done successfully or not. Just write show VLAN brief. Wow, you can see we have right now 2 VLANs. In VLAN 100 that 2 interface has been assigned, in VLAN 200 that only 1 interface it has. So the VLAN configuration for switch 1 have been done. Now we are doing the same configuration for switch 2. Now you can see the same configuration, but with only one difference. The host name is SW2. We are copying each part, the first part, and go to the switch 2 terminal and paste it. Now come to the second part and copying the VLAN configuration and paste it into switch. Now go to the third part and copying this configuration. Here is only the difference that the interface range is a bit different because we have only a server and PC4 that are connected with different ports. Just copying this configuration and paste into the switch CLI. And now let's see, are the same VLAN configuration have been done on switch 2 or not. Just write show VLAN brief. Yes, the same configuration have been done for both switches. Now if you would like to save the configuration on Cisco switch, just type the WR command and press enter to save the configuration on switches. Voila! Now we have network infrastructure with 2 VLAN configuration and divided the connected computers into separate VLANs. Boom! Let's jump to the third stage. In the third stage, we are checking the connectivity for all the connected computers. For the time being, I have assigned the same class IP range for all connected computers to check are they able to ping each other because they are now in the separate VLANs. Let's ping PC2 from PC1. Open the packet tracer and open the PC and click on CMD. Just ping and enter the PC2 IP address. Wow, it's successful because it is in the same VLAN or VLAN 100. Now let's ping PC3. Oops, it's not success because we know that they are in different VLAN. We reach to the final stage to ping PC4 or server from PC1, but it is required to configure the trunk link between the switches. Either if they are in the same VLAN but in different switches, they will not be able to ping each other. So let's see the further process. Simply you might ask, what is a trunk link, or also called a trunk interface? A trunk link is a special type of link between the switches that carries traffic for multiple VLANs. Instead of needing a separate cable for each VLAN, a trunk link allows all VLAN traffic to pass through a single cable or connection between the switches. Let's see the following diagram to understand practically why exactly do we need a trunk link between the network diagram. As we understand about the network infrastructure, that PC1 and 2 are in VLAN 100 and PC3 are in VLAN 200 in switch 1. In the other side, in switch 2, PC4 are connected in VLAN 100 and server are connected in VLAN 200. So in this network diagram, PC1 will ping PC2 but not able ping PC4 because we are sure that they are in the same VLAN, but they are not connected in the same switch, because the link, as you can see, between the switches as a first Ethernet 04, this port is not specified that belong to which VLAN. So if computer are in the same VLAN but in different switches, they will not be able to ping each other because the link between the switches is not specified. So the same for VLAN 200. But if we would like that PC1 and PC2 are ping PC4, we have to identify or connect another cable from one port switch 1 to another port on switch 2 and specify that port on exact VLAN, I mean VLAN 100. Thereafter, PC1 and PC2 will be able to ping PC4. Otherwise, we need to configure that trunk link between the switches. So this is the benefit of the trunk, because we can use one interface instead of many to carry out or transferring data between different VLANs. For your further understanding, we have two types of port for VLAN. One is access port and one is trunk port. In access port, we are connecting the endpoint devices like printers, computers, and server. In the trunk port is connecting between the switches, or the trunk interface is used between the switches to transfer different VLAN data. Now simply you might ask, if different VLAN transfer across one link or a trunk link, how the switches could identify this data is belong to which VLAN. Simply the switch is using a protocol 802.1q to identify each VLAN data. It means when a switch received the data, it is identifying belongs to which VLAN and adding a tag or tagging the data and specifies that is VLAN 100 or VLAN 200. Thereafter, it is forwarding the packet to the second or third switch. And when the second switch receives the same data, it is removing that tag and forwarding the data to its exact destination. Simple, right? So finally, we are reached how to configure the trunk link between switches that both switch will be able to transfer different VLAN data among them. So I have write all the configuration in the notepad. Just copy this configuration and go to the switch 1 and go to the configuration mode and enter this configuration. So the trunk link has been configured for switch 1. Now go to the switch 2 configuration. On a notepad, copy all the configuration, open the switch 2 CLI and paste the configuration. So the trunk link between the switches have been successfully configured. So to check PC1 is able to ping PC4. Now let's open CMD from PC1 and ping the PC4 on another side. Yeah, it is now successfully pinging each other. So the trunk link between the switches have been successfully configured. Ding ding ding! If you found this video helpful, don't forget to like and subscribe to the channel for supporting me prepare more videos like this. In a summary, we found that VLAN configuration or implementation is very important for our network infrastructure because it will help us to improve network security, reduce congestion, and will give us flexibility with cost efficiency. Plus, we understood the trunk link benefit between the switches because it will help us to use one cable to transfer different VLAN data between the switches. Otherwise, we would like to use different cable for different VLAN. In the next chapter, we will talk about STP or spanning tree protocol that can help us how to remove the loop in our network. Thank you so much and Allah Hafiz.